energy. Specifically, we're going to be talking about kinetic energy, and we're going to be talking about potential energy. And this is something that you should have seen in 8th grade, because I taught 8th grade for a number of years, and I distinctly remember going over energy. Do you guys remember the difference between, or the similarities between kinetic and potential energy? Which energy is for which situation? Do you guys remember?
Isn't the kinetic when it's moving like down or like has momentum or something, and potential is just like it's still?
Yes, exactly, Madeline. Perfect. Couldn't have said it better myself. So absolutely. Potential energy is just kind of when it's chilling. It's not doing it yet, but it has a lot of potential, right? How many times have you heard that yourself? You have so much potential. It just means that it has the ability to do it, right? It has the ability to give off this much energy. And then when it goes from sitting still to moving, exactly like Madeline said, it switches from potential energy into kinetic energy. Remember that term kinetic, kinesis, really has to do with motion, movement, right? So that's what you're going to expect. And so this lab specifically, and let me go ahead and start sharing my screen. This lab specifically is going to be talking about the conservation of energy. So again, something that you should have learned about before. Does anyone remember what conservation of energy means? Thinking of that word conservation. We've used it a lot in science. We just used it when we were talking about the conservation of momentum. What is it? What does it mean to conserve something? If you're trying to conserve it, what do you think that means? Saving, exactly, Julie. So when we're talking about conservation of energy, we're talking about saving that energy. So we have an equation. How much energy should be on one side of the equal sign and the other? We're trying to conserve energy. Would you expect one side to be larger, one side to be smaller of the equation, or would you think it would be the same?
The same?
The same, Abby, exactly. So the conservation of energy is talking about the energy before the system or in the system is going to be the same before the event and after the event. And you'll have a chance to learn about this when you go through your lessons this week. So this lab is not scheduled to happen until the 12th, which I believe is Wednesday. So you're going to have this lab due Wednesday. So today we're really just going to talk about it and go ahead and help set it up, because it is a little complicated to set up. But we're going to be doing an experiment where we're going to be able to see and calculate the amount of potential energy and then compare it to the kinetic energy and see if we've lost energy or not, and use that evidence to provide evidence for the conservation of energy. So good. So a couple of things. Remember, we already talked about kinetic energy, energy that moves, potential energy, energy that has the ability to have this much energy, right? Usually it's not an object that's moving. It has to do with height. So we've got two equations that I want you guys to write down right now. And again, you'll get to these equations in your lessons, but if you haven't started the unit yet, these are going to help you understand the lab. The first one is the kinetic energy. So if I go ahead and really quickly switch to my whiteboard, because you guys know I love drawing on my whiteboards, kinetic energy, or also represented as KE, okay, so kinetic energy is equal to 1/2 mass times velocity squared. Okay, so that velocity is going to be squared times the mass. Remember that we want the mass to be in kilograms, and we've got 1/2, okay? And then for potential energy, This is the object that stays still. We have mass times gravity, or, right, remember that gravity is also the same as 9.8, so long as it's on the Earth. If there's a word problem that says you are on Mars, then maybe it's time to dig a little deeper about what that G is. We're not going to use G at that point, right? And then the last thing is height, so mgh. So there are your equations.
So potential energy is mass times Wait, what was it again? What was the G?
The G is the acceleration due to gravity, so that 9.8. Sorry, it's not my best written.
It's okay. So then what's the H again?
Height.
Okay.
So how high off it is to the surface of your surface. Okay. All right, let me know when you guys have written this down. Either give me a thumbs up in the camera or type ready in the chat. Great, Julie, thank you. Awesome. Got it. Sam, how you doing? You wrote these down? Great. Okay, let's go ahead and actually take a look at the lab. So I'm going to start off by looking through the investigation slides, right? So these are the investigation of conservation of energy. I kind of skipped, just so you know, when I went to the actual lesson where I clicked on 3.5, I already went through the introduction. So the introduction is going to kind of give you a brief overview of what I just gave you, reminding you of what kinetic energy is, potential energy. And then it's going to give you that note sheet. So I'm just going to skip the introduction and go to the laboratory. So now we're in the laboratory section of 3.5, just so you know where I'm getting this information, because I'm also going to show you where you should be downloading the instructions for the lab. So like I said, 3.5, click on the laboratory section, and it's going to tell you a brief overview of what we're going to be doing. It's using this example of a roller coaster, right? So when we talk about roller coasters, we are thinking about the conservation of energy, because it is, and they're going to relate this to the work that is done, right? So what we learned last unit. It's going to tell you that, the cars go to a height h above the starting point, and then as it goes over that spot, it's got so much potential energy, it's going to then switch to kinetic energy, and it's going to try to use all of that potential energy that it built from going up higher and higher to go faster and complete some of the rounds before they include more energy. So it's kind of telling you it's telling you that the work done is equal to the work required to lift the car straight up. We just learned about work, right? We just talked about the force of an object moving in the same direction of the force being applied is what work is. Since the force needed to equal the weight mg of the total mass m, right? Remember, weight is that mass times gravity. So it's talking about the total mass of the cars and multiplying it towards gravity, the work required, and then that height. So remembering that the height is how far it travels. So it's just connecting. All it's doing right now is connecting last unit to this unit. So we're talking about the work being done, and now we're talking about how that translates to energy. So the kinetic energy, here we have our equation, 1/2 mv squared. The gravitational potential energy gets smaller as the kinetic energy increases, because potential energy is transformed to the energy of motion. So again, remember we talked about the conservation of momentum. It just changes, right? That mass times velocity, it goes from one object. If it collides with another, it transfers that momentum over. Well, it's the same thing here. You got that potential energy, and the more and more it starts moving, the less potential energy it has because it's going closer to the Earth, and the more kinetic energy it has because it's starting to move faster and faster. So kinetic energy and potential energy have this relationship, opposite relationship, okay? So keeping that in mind when it comes to graphing and understanding the quantities of each. So here's a little preview of what you're going to be doing. Since we can't bring a roller coaster into your home, as much fun as that would be, we're going to have to simulate a roller coaster. And we're going to do that by creating these inclines. So today I figured that we would spend some time, hopefully if you have a space in your house, since technically the lab is not due until Wednesday, at the very least for today, I would like for us to build the ramp and build the lab so that if we meet again in small group on Wednesday, we can go ahead and collect the data. So all of it is set for you. So what we're going to need to do is we are, when we go to that next slide, okay, so now we are going to be moving from the laboratory conservation of energy and we are moving into investigation. Okay, so let me just show you how I got there. I clicked on these arrows, but you can skip there if you go back to your lesson homepage. That looks like this. 1 second. Okay. It's going to look like this. Then what you're going to want to do is go to the investigation. Okay, so the conservation of energy 1 investigation. And that's where you're going to find the documents that you will need to download. So on that first slide, it's going to tell you this is going to be over 2 days. Really, it's just 1 day. I put them on the same for our learning target. You've got graph paper if you don't have it. Here are the instructions, and then here is the lab report. So it does seem like you're going to be turning in the lab report. Let's take a look at the lab report first, just so we know what's expected of us, whether it's going to be a discussion or an actual lab report that's written. Okay. So these are the questions that we're going to be answering and submitting in our lab report. So a couple things to keep in mind while you're starting to get familiar with the lab. So a couple things we're going to try to figure out. Did changing the angle of incline affect the following parameters? Did it affect the velocity, the work being done, potential energy, final kinetic energy, right? And why or why not? Then we're going to ask a question, how did velocity and velocity squared relate to the height from which the ball was released? So trying to make some connections between velocity squared and height. And then what general principle can you conclude about work, potential energy, and kinetic energy from these experiments? So trying to make that connection between what we've learned so far. I've talked a lot of like preface to the lab itself. Are there any questions so far? Or are you guys like, all right, Ms. Bierstein, let's just get to setting this up? A little bit of the.
I'm good. I don't know.
Okay, great. Thanks, Madeline. Anyone else have any questions? Okay. So, like I said, on that first page of the investigation section, you're going to come across to all of those downloads. So why don't we all get there right now? Whether or not you're going to be actually completing the lab, I still would like for all of you guys to go ahead, click on that link that says Laboratory Instructions, Conservation of Energy, and let's open that up. And then Madeline, don't forget that when you open it up, let's open it as a Google Doc too. So that way you can get all of your equations and we're not missing anything now that we've finally figured it out. All right, let's zoom in. Okay, and so all of this information is going to be also listed in the slides. So, all right, Abby, no problem. Let me know if you have any questions later. All right, so we've got all of these materials that we're going to need, and all of this is going to be coming from the box, the kit that you got from Q2. So you should still have that. And so you should have the student guide, which is this graph paper, lab guidelines, and then you'll need the ramp kit, the steel ball, the stopwatch, the measuring tape, protractor scale, electronic scale, ruler, and clay. You'll also need some books and some masking tape if you have it. Okay, so let's go get all those materials first. And then I personally want to kind of go through this a little bit more before we get to the document. But let's go ahead and grab our materials. If you don't have the materials, then just do it, you know, mentally, right? Pretending like you're a part of this. Oh, good. This is not easy. Okay. All right, I got my lab kit. Let's see here. Okay, so I've got my track. So your track.
Do we need to do something like the floor or something?
Yeah, you want something that's going to be on level ground and something that's going to be able to like go a longer distance. So I would say the ground would work.
Okay.
And then you're going to want some modeling clay, which comes in this box. Okay, this yellow box, and that's just for stability. And then you should have a metal steel ball. Your digital scale that comes like this in a box. Okay. Stopwatch. I got the steel ball. And I'm just looking for the stopwatch. Worst comes to worst, you'll just use your phone or a web browser. Oh, here's the scale. Fell out of the box. All right. You guys got your materials? All right. So once you get your materials, then we're going to go ahead and start setting it up. So a couple of things that we really need to know is the two parts of the lab. So let's go over those two parts of the lab so that we can get an idea of what we're going to be doing with our lab kit once we go ahead and set it up. But for right now, I'm going to tell you about part 1 and part 2. Part 1 is really going to be talking about the angle. So we're trying to measure the potential energy, kinetic energy, and work. You are going to be connecting two pieces, and there's a video that we're going to watch that also shows you, and it's in the lab lesson. So we'll have multiple different sources. So we'll have different sources to kind of show us what we're going to be doing. But the first part of the lab is really going to be talking about the angle of incline, and meaning that the way that we change the height. So this is going to be one angle, right? So if we're going to be making our track and then stacking it on a bunch of books, right, to change the angle. No problem, Madeline. The angle that we're going to want to be changing is this angle right here, this one to the ground. So if you like put it down and rest it on a book closer or farther away, that angle from the floor here and right here is what we're going to be measuring. So you're going to need, but I'm going to need to have a protractor to measure that, which is right here. Now, the ball is going to be dropped at the same place on the ramp every time. So what you might want to do for that is to make sure that you are putting a piece of tape. And so no matter what the angle is going to be, whether it's like really, really high or really, really low, you're always going to be putting that steel ball in this one place. And that's part one. Okay. So just changing the angle in part one. Part two, you are actually going to keep the angle the same, but now you're going to be measuring the ball from different parts. So whether it's up here and then down here, each time measuring it up the ramp. Okay, so that's basically what the two parts of the lab are going to be about. But like I said, we're not going to focus so much on how to actually conduct the lab. Today, we're really going to be focusing on how to set it up. So this does a pretty good job of explaining it if you are better with like step-by-step instructions. But I'd like to show the video quickly, just so that way we can all be seeing the same thing. So let's go to the video. So again, it's going to show you how to measure the angle. So when you connect it all, it's going to show you that angle, where to measure it, which is right there. Okay. And then if you keep going, it's going to even give you some support and what it should look like. Different, remember I told you during part two, it's going to be, you're going to keep the same angle, but you're going to roll it from different heights. And here is the video. So let's watch the video first. Can you guys hear it?
No,
You guys can't hear that?
I can't.
Okay. I wonder if it'll let me. Hold on. Stop playing. Let's see. What about
Still can't hear anything. You're muted. I can't hear you.
Thank you. And while I'm figuring out how to share it with everyone, why don't you guys go ahead and find this video in your lesson, right? So you should be following along with me on Fuel Ed. So why don't you go ahead and locate page 5 of 5 in the investigation section of lesson 3.5. Okay, it is going to hopefully be accessible in a moment. But in the meantime, this is probably going to be one of the more challenging labs to set up, but you can take a look at what he's got so far. You are going to want a couple of books. Remember that you have a whole kit, so you should be able to make a ramp. This is the shorter one is going to be the incline. So this is what you're going to be doing the ramp out of. okay? And these longer pieces, okay, so then you're going to have these longer pieces, you're going to make a whole like long ramp of as well. And the whole point is to keep that distance, and you're going to want to keep it to about a couple of pieces. I wonder if they have it specific in the lab. Let's take a look. So it says create 2 sections of track. One section will consist of 1 connector piece and 2 plain pieces. The second section will consist of 4 connector pieces and 6 plain pieces. So these are the connectors, the see-through, and these are the plain pieces. And so you're going to want to get 4 of these. Oh, excuse me. What did it say? 6 of these and 4 of the connectors. Right? Yep. And that's how long your ramp is going to be. Okay. Got it. All right. So, why? Is it because I made it private?
I have one that was like from already built from like last quarter. Does this work?
Great. Yeah, as long as the ball can move through it, that could be part of your bottom one.
Okay. How long does it need to be?
It says that you're going to be using consist of 4 connector pieces and 6 plain pieces. So I assume the clear one, right? Isn't this clear one the one that is the connector? I would assume.
Yeah, that's the connector.
That's what I thought.
This has 3 on it. 3 of
Great.
the
So
clear.
you just need 1 more connector or 2 more, 1 more, and then 6 plain pieces. Okay, now I have to try to make this not private. Maybe that's what the issue is. Okay. Now let's see if we can make this work. All right, so this is going to be a little video of how you're going to set it up. Let's watch it all the way through, and then we can pause and work on it together.
Hi, my name is Pat.
Okay, so let's pause right there. So let's go back and just start by making those connecting pieces. Okay, so the first one is going to be the 2 shorter ones. See how there are 2 different, well, I guess there aren't, there's just seems like there are, but there's going to be three of these, right? So 2 of these black pieces and then the 1 plastic connector. So that's going to be that incline.
How are we going to connect it though to the flat panel?
You mean connect it from piece to piece or connect?
No, like because it's like it says one part is like diagonal and then it goes straight. How are we going to connect that?
We're just going to try to put them as close together so that the ball moves smoothly through it.
Okay.
Yeah. There we go. All right, I've got my ramp part of it. So this is the part that I'm going to have inclined. And then you're going to connect, it says 4 connectors and 6 of these of the remaining. So we've got these, they slide in and they make like a little V. Are you guys all doing this? Sam, I know that you're going to do this when you get back. But Julie, Madeline, Abby, are you guys working on building the ramp?
Yeah. I'm kind of like done though because I already had like the ramp put together from last quarter. So just adding the second part.
Great. So then you should move on to, do you have the lab in front of you?
Yeah.
The material should have been in that box, Julie, and the one that was sent to you for last quarter, that one with all the lab materials. Yeah. Okay. Well, make sure that you get them in nicely, I suppose. Okay. I've got 2. All right, good. Welcome back. Okay, so we should have about a meter when it comes to all of it. All right, so let me know when you guys are ready to move on to the next part of the video. So we've connected all of our planes and all of our tracks. Let me know when you're ready for the rest of it. Okay. Well, why don't you show me, Abby, and I can let you know.
Okay. I had to leave for a second, so I wasn't here for all of it, but it looks like this.
Yeah, good. And it should
And
be
then I have this one.
perfect. Yep. So your
Okay.
long one should be about 1 meter, and then you should have only one short one, and that's going to be your incline. So that's going to be like, essentially, it's going to look like this, right? They're all going to meet up. And then this one is going to be the incline, and then the ball is going to fall on here and roll down the rest of your tracks.
Okay. Wow.
Good. All right, then I'm going to go ahead and play more of this video so we can see what else is coming. So that is the overview of the lab. So like I said, we're not going to be collecting the data today. We're just building it. So try to find a space where you can, that will be safe. Maybe ask your grown-ups at home where you can do it if you can. And if not, then you'll just have to remember exactly how to set it up for Wednesday or whenever you get to this lab. But essentially, the most important thing for today is understanding these two parts and knowing how to build it. You are going to need a couple of books or something that you can lean the ramp on. You will want to double check the ramp multiple times to make sure that the ball can move through it seamlessly, okay, without any sort of bumping off or hiccups or anything like that, okay? So you are going to want to do that. And then you are going to want to go ahead and create your long ramp, and then whatever the ramp is, your long track, excuse me, the ramp is the incline. And then with your track, you're going to measure it to find the length of the track it's going to go. You're going to measure it from the point. So we have our incline. Okay, so here is the incline, the ramp that the ball is going to go down. You're going to start measuring your track from where it flattens out. So if you see my finger, like right here, all the way to the end of the track. And that's going to be your measured distance. And it's going to have you record that in your table. So every time that you change the incline, you're going to go ahead and put in the degrees. Remember, using your protractor, measuring it from the table to the angle that you put it up on the book. So if I put it up this high, then my angle is from this point, measuring it flat from the bottom and this point right here. Okay. Then you're going to do the height it is off of the table. You're going to measure the height it is off the table. You're going to write down the length of the incline. The length of the incline is how far up the length of the incline it is. So is it here? Is it here? Is it down here? Right? You're going to measure up the incline. The horizontal distance is your track length. The time it takes for you to drop it and for it to reach the end of the track. And then you'll multiply the velocity, knowing that the equation for velocity is distance times time. Okay, and then you'll get the average velocity because you'll want to do each one every at least 3 times for each angle that you change it for part 1. And then you'll want to get the mass of your steel ball using that, using the scale, and pay attention, it wants it in kilograms. So in this scale, it may give it to you in grams. So you'll need to convert it to kilograms. Okay, so that's something to be paying attention to. And that is part 1. Part 2 is very, very similar. The only thing is now you are not, you are going to be changing where you start the steel ball. Okay. All right. That's everything I have for you today. We're just setting it up. When I see you for small group this week, we're going to start collecting data. Do you guys have any questions for me? All right. Well, there are no more questions. That is your Monday. Thank you all for joining me. Again, make sure that you are emailing me with questions. Otherwise, I'll see you on Wednesday for small group, which is also the day that this lab is due. So we'll be working on the lab for small group.
Thank you.
Thank you.
Yeah, you're welcome. Bye, everyone.